Although these human systems are great, we need to find new technologies to understand the basic biology.
You mean like a tool that you could use to look more closely at what's going on inside of your organoids?
Exactly. We need to be able to separate them from these other highly abundant cells in these organoids. What can we do to solve this problem?
One must wonder, how many times has a scientist with a compelling hypothesis had the painstaking, nagging question, if only I had the right technology? Science tends to study what we can study, and instrument development and biology move fastest when they move together. When they're developed separately, it takes about 40 years to fuel breakthroughs. However, that gap shrinks to about 7 years when they're developed together. Today, the problem is commercialization. Tools must often first prove they're marketable before scientists can use them, which decouples instrument developers from discovery. Or rather put, if the market doesn't call for it, engineers don't build it. And if engineers don't build it, biologists can't discover with it. Here at the Wyss Institute, our instrumentation program recouples the efforts of engineers and biologists, giving something they truly need for their cutting-edge research, resulting in breakthroughs that happen potentially years, even decades sooner. What's more, at the Wyss, we have a strong record of supporting the advancement of scientific discoveries to commercialization. So this instrumentation program bridges this gap by educating budding entrepreneurs on cutting-edge technologies typically not found in academic labs, but indispensable in industry settings. Okay, Don. So, what makes you most excited about this program?
Well, it offers a lot to our researchers and to our partners. It allows us to have state-of-the-art technology that advances science, because science is always limited by the technical capabilities that are out there. But the other way around, our partners get to have incredibly broad community of creative people using their equipment in new ways, collaborative ways, exploring capabilities maybe they didn't even think about. And that great value is when you have concurrent development. Sometimes there could be technologies we develop that could add on to a technological capability that a manufacturer has produced to create something new, which can then be a licensing agreement.
What's one thing you'd like to tell the current participants of this program?
Well, we're incredibly thankful. I mean, I think it's been a really great experience across multiple different manufacturers, and so we hope to do more of it.
Yes.
As part of our DARPA RBC factory program, we have this very interesting idea of being able to use red blood cells to move cargo around the body. In this program, we're using devices from various collaborators in order to achieve this. One of those devices is the portal device.
We use the portal device to rapidly open cell membranes to allow us to deliver cargo into the cell without the use of any chemicals. It allows delivery of any size molecule.
We're working with Ramona's Virio system to find treatments for bipolar disorder
and to standardize the organoid generation for high-throughput applications.
We use 3D printing and fabrication from UpNano to design and prototype point-of-care diagnostics.
The Brigham Wyss Diagnostics Accelerator has leveraged the analytical capabilities of SciEx to turn molecular insights into diagnostic solutions.
We're using water's analytical technologies so we can measure contaminants to build a more sustainable future through technology innovation.
We use liquid handlers from Tican to automate the process of analysis and growing the organoids that we're developing here at the Wyss Institute. We use this automated technology to find out new drug targets to fulfill unmet needs in the hospitals that we're working with.
We rely on liquid handling technologies from Biodot to develop novel biomarkers for diagnostics that could help save lots of lives.
We are leveraging the Agilent Seahorse to develop new types of anesthesia that can be used in scenarios without access to critical monitoring equipment or medical personnel.
By coupling innovative instrumentation techniques with cutting-edge research, the Wyss Instrumentation Program has driven impact across diagnostics, drug development, and sustainability. What future discoveries may yet emerge from this synergistic effort? Well, we look forward to finding out with our instrumentation partners.
And I've engineered these organoids to move us away from animal models for drug discovery and more efficient clinical translation.
But we'll need new tools if we're going to be able to get the most out of your organoids.
Well, thanks to our instrumentation program, we have a vendor who could accomplish just that.
That's so amazing. I'm excited to try out these new solutions.
Yeah, this sounds like it's going to be fantastic.
I'm so excited.
I am too.